Now, the question is, well, why is this the important idea for how to win this game? Very simple, actually. And by the end, you started to get quite good at it. Even if you weren't able to articulate it, you started to get an instinct for why, an intuition for why certain numbers will work, will win, and others will not. Okay. So the question I'm going to phrase to you is, how can we represent the sample space? How can we show all the outcomes you can have? Let's just give a quick example. Okay. If you were just rolling one die, okay, there are only, well, how big's the sample space for one die? 6. And because 6 is a small number, I can literally just list out what the options are. There you go. There's the sample space as a list. That's important. Okay? Listing out is really good because then you can see everything in front of you and you can work out exactly what's happening. But when you go just from, all you have to do is add one more die, right? It becomes more complicated because this die has 6 possibilities and this one also has 6 and they're independent of each other. Okay? So with one die, okay, that's 6 possibilities. Right? When you have 2 dice, how many possibilities are there? 12. Now this is interesting. If we list them out, you will find, don't forget, there's blue and green, right? There's much more than 12. Watch, I'll show you, okay? Let me show you. If I say, well, okay, here's the blue one, and here's the, well, anyway, there's the green one, okay? Let me start listing them, okay? Suppose the blue one is a 1, okay? You can get a 1 over here, get a 1 and then a 2, 1 and then a 3, 1 and then a 4, 1 and then a 5, 1 and then a 6. We've already got 6 possibilities, right? That's all of the different things a green can be. So now what should I do to get more possibilities? Have a look at the blue one. Let's put a 2 there. And then I can keep going. 1, 2, 3, you get the idea. Now by the time I get to the end of this column, I've already got listed out 12 possibilities, but there's more. There's more. Look, I'm missing all of the 3s and 4s and 5s and 6s. Now, two things. First, that means that there are not 6 or 12 possibilities. How many are there really?
36.
There are 36. 2 dice. Because one die has 6 and the other die has 6. It's 6 times 6 or it's 6 squared. If I had 3 dice, it'd be 6 cubed and on and on and on. That's 36. Okay.
Oh, I was working on something.
Yeah, different problem. Now you can see, with this number, no problem. List it, that's fine. With this number, well, you got 2 issues. Number 1, it's just going to take a long time to write. Okay. Number 2, you might forget one if you don't lay it out in a logical order. Okay. So listing, as it turns out, is not necessarily the best way to represent your sample space. Let me show you a better alternative. Kind of. That tends to be more useful in statistics. Here I'm trying to work out probability, which is related, but different. Make a little subheading for yourself. This is called a dot diagram. Okay, now raise your hand. Who's heard of this phrase before? It doesn't matter if you remember what it is. I just want to see any familiarity. All right, great, hands down. Here's what a dot diagram looks like. I will pull out my colors this time. Okay, we've got 2 dice, and instead of listing them downwards like this, I'm going to list them in different directions. Okay, I'm going to go horizontally and vertically like this. I'm going to have my blue possibilities up the top, and then I'm going to write my green possibilities down the side. Okay, so like I was saying before, right? The green die can be 1, 2, 3, 4, 5, or 6. The blue die can also be 1, 2, 3, 4, 5, or 6. Okay, now here's where the name of this comes in, right? When you have it represented in a grid like this, okay, you can represent all of the possibilities by saying, well, look, see this one? 1, 1, right? It represents, well, I'm just going to put a dot there. That represents one possibility. A 1 for this and a 1 for that. I've got another possibility here, here, and I can put a dot for each one and then read off. For example, if I put dots out here, I can look at this dot and say, look, it corresponds to a green 3 and a blue 5. So I'm going to count up 36 dots. like so. Okay. This dot diagram here is useful in that it shows us all the possibilities, but it's not very descriptive. So we're going to upgrade this a little bit. The reason why I showed you this is so you understand where the name is coming from, okay? But we can put more information on here, because what happens, right? When I actually rolled this, and I rolled it, and suppose you saw 2 1s there. You actually don't think of it as 2 1s, you just think of that as a 0. Yes, that's the important bit about it. So here, on this dot, on top of that spot, I'm going to write 0. That's what these two together would mean. That's the result. Now, that's not the only 0 there, is it? There are other results that will give you 0, because you played and you felt it. Where else can I put zeros?
2, 2.
I can put it on 2 and 2. 3 and 3.
4 and 4, 5,
I can keep going, can't I? In fact, there's a diagonal traced out by the zeros. Okay. Is there anywhere else, any other combination of dice that can give me a 0? That's it, isn't it? That's it. Okay. Now I can have a look at the other numbers. Yeah.
I just figured out, with 0 you can have 6, with 1 you can have 5, then it adds up to 21, but like, I did the thing, so it's like, with 5, right, you can only get it once, 6 minus 1.
Well, okay, almost. Let's finish this diagram, okay? And this will show you the answer, okay? Those are the zeros. What do you think is the logical next thing to put in?
1.
The ones. Where are all the ones going to go?
Both sides of the zeros.
Good. So for example, here, if I roll a 2 and a 1, that's a 1. But if I roll a 1 and a 2, that's also a 1. And you can see the pattern continuing. If I got a 3 and 2, that's a 1. A 4 and a 3, a 5 and a 4, a 6 and a 5. They're all 1s. And there's a symmetry to it, right? Because the dice are the same, I'm getting the 1s up here as well. You're starting to see the pattern now, aren't you? Where would the 2s go?
Next to the...
Just keep going. Just keep going, right? 3 and 1, 4 and 2, 5 and 3, 6 and 4. And the equivalent on the other side. My diagram's a bit shoddy, sorry. You get the idea. I still have 3s to put in. Have a look. This is the key to winning. This is the real key to winning, right? The probability of a 0, right? What's the probability of 0? Well, we remember the probability is favorable outcomes over sample space, right? Well, there are 6 ways to get a 0. And there are 36 total outcomes, so there's 1 out of 6. Okay. Now, for your homework, what I want you to complete is, I want you to work out what all of these are as fractions and also as percentages. I happen to know that a 6th is about 17%. What's the probability of getting a 2, or a 3, or a 4, etc.? And we will discuss it tomorrow.